string to integer, atoi, looks simple, until whitespace, signs, leading zeros, junk characters, and overflow crash your solution. This Pattern Mastery 100 Classic shows up constantly because it tests careful parsing and boundary control. Today we'll turn chaos into clarity with basic and ship an interview-proof implementation that clamps to 32-bit signed range. Breakdown. Given a string s, convert it to a 32-bit signed integer with these rules. Ignore leading spaces. Read optional plus or. Read consecutive digits. Stop at first non-digit. If no digits are read, return 0. Assess. We'll do a single left-to-right pass with index I. Track sign, plus or minus 1, and res, the number. For overflow safety, before adding a new digit d, check whether res greater than int_max//10 or res equals int_max//10 and d greater than 7. Because int_max is 2,147,483,647. This runs in on time and O1 space. Structure. Skip spaces. Read sign if +/. While next char is digit, convert to d, pre-check overflow, update res equals res 10 plus d. Return sign res, already clamped. Let's try to implement it using solution 1. We begin by stripping the string of any leading spaces. Think of this like trimming off blank padding before reading a number written on paper. This ensures we start parsing exactly where the meaningful characters begin. Here we check if the string is now empty. If someone passed something like comma-only spaces, then after trimming, nothing remains. In that case, the correct return value is simply 0. Handling the sign. We set a default sign of +1, assuming the number is positive unless proven otherwise. This index will keep track of where we are in the string as we process it character by character. Next, we check if the first character is a plus or minus sign. This tells us whether the number is positive or negative. If the character is a minus sign, we update sign to -1. If it's a plus sign, we keep it as positive. This is just setting the correct direction for the final number. Since we've processed the sign character, we move the index forward so the next step reads the digits correctly. Preparing to build the number. Here we set up a result variable that will accumulate digits to form the final integer, like assembling the number one digit at a time. We define the limits of a 32-bit signed integer. These bounds are required by the problem. If the number goes beyond this range, we must clamp it. Processing digits. This loop runs as long as we still have characters to check and the current character is a digit. If a non-digit appears, like letters, we stop immediately. The loop runs at most on where n is the length of the string. We convert the character into its numeric digit value. For example, 7 becomes 7. This works by comparing ASCII values, a common trick in parsing. Checking overflow. Before we multiply or add anything, we check whether adding this digit would cause the number to overflow the 32-bit integer range. If result is already too large, adding another digit would break the limit, so we'd need to clamp the value. If adding this digit would cause overflow, we immediately return the appropriate limit. int_max if the number should be positive. int_min if the number should be negative. This satisfies the problem's constraints. Building the number. We safely shift existing digits left, multiply by 10, and append the new one. It's exactly how you'd form a number by hand. Write down the old number, then stick the new digit on the right. We move on to the next character so the loop can continue building the number. Finally, we apply the sign we detected earlier and return the completed integer. This gives us the correctly parsed number per the rules of the classic atoi conversion. Solution 1. Case 1. Let's test our function using this input, 42. This string represents a simple, clean, positive number with no leading spaces or signs, just digits. Here's why the solution works. The algorithm trims whitespace, sees no sign symbol, and begins converting each digit one by one. The characters 4 and 2 become the number 42, with no overflow issues. And that's exactly what our program outputs, 42. This confirms that our code is working correctly for a standard positive number. So, our implementation is correct. It successfully parses plain numeric strings, efficient, accurate, and reliable. Let's try to implement it using solution 2. We start by importing Python's re module, which stands for regular expressions. This gives us powerful pattern matching tools so we can scan the string and pick out the number part cleanly. This defines the solution class, just the standard wrapper many coding platforms use. Our function will live inside this class. Here we define the method myAtoi, which takes a string s and converts it to an integer, following the special atoi rules: skip spaces, handle sign, read digits, and clamp to 32-bit range. We first call lstrip on the string. This removes leading spaces from the left side, kind of like trimming blank space before reading a number written on a page. Now we use a regular expression to grab the numeric part at the start of the string. Caret means start of the string. \+ means an optional plus or sign. \d+ means one or more digits. So this pattern says, from the very beginning, optionally read a sign, then read as many digits as you can. Re.match tries to match this pattern at the start of s and returns a match object if it succeeds. Here we check, did we actually find a number like pattern? If match is none, it means the string didn't start with a valid sign plus digits combination. In that case, no valid number at the front, we simply return 0, as the problem requires when there's nothing numeric to parse. Now we're in the case where the regex match something. Match.group0 returns the exact substring that matched the pattern, for example -42 or +7 or 4193. We store this in num_str. This is our clean number string, ready to convert. Here we let Python do the heavy lifting. We convert the match string directly into an integer using int num_str. So if num_str is -42, num becomes the integer -42. This comment explains the next section. We'll make sure the number stays within the 32-bit signed integer limits defined by the problem. We define the upper and lower bounds. int_max equals 231 to 12,147,483,647. int_min equals -231 -2,147,483,648. If our parse number goes beyond these, we'll clamp it. We first check for underflow. Is the number smaller than the minimum allowed 32-bit sign value? If it is, we return int_min directly. We don't let it go any lower. This guarantees the result stays in range. Next, we check the other side. Is the number larger than the maximum allowed value? If it's too large, we clamp it down to int_max and return that instead. If the number is safely within the 32-bit range, we just return it as is. No clamping needed, it's already valid. Solution 2. Now we try the input, 042. This string has leading spaces, a negative sign, and digits with a leading 0, a very common real-world format. First, we strip the spaces, so we're effectively looking at 042. The regex matches the longest prefix that looks like an integer, 042. We convert that to the integer -42, then clamp it if necessary. It's safely within range, so we return -42. And that's exactly what our program outputs, -42. So the trimming, sign handling, and leading 0 logic are all behaving as expected. So, our implementation is correct. The algorithm successfully parses the longest valid signed integer prefix from each string, then safely clamps it to 32-bit range, efficient, accurate, and reliable. So that's our deep dive into string to integer, or the famous atoi challenge, a classic test of precision and control under pressure. Breakdown recap. We started by understanding the task, turning a messy string into a clean 32-bit integer while handling whitespace, optional signs, random junk, and possible overflow. It's all about disciplined parsing and staying within boundaries. Assess recap. We looked at how a single left-to-right scan can get the job done efficiently, keeping track of sign and digits while staying mindful of integer limits. No fancy tools, just logic and order. Structure recap. Our plan was simple: skip spaces, catch the sign, read the digits, and carefully check for overflow before updating the result. Each step built naturally on the last, leading to a clean, predictable flow. Implement recap. We coded it up, ran it on LeetCode, and everything executed perfectly, no errors, no surprises. Check recap. After running through all the test cases, the logic held up across edge inputs, from empty strings to overflows, confirming our approach works end-to-end. The big takeaway? Even simple-looking problems can hide layers of complexity. The key is calm, structured thinking, step by step, just like parsing this string into a solid integer.